All right, I'm not muted this time, so we're good to go. So I said we're going to do one of each section together, which leaves, I'll do the odds with you, which leaves you the evens to do at home. So let's go through part 1. That's good. So for number 1, we have the cosine of 8 over 3 pi. And we want, for part 1, we're asking to find the value. All right, the first thing we have to decide is if we're going to divide or if we're not going to divide. Remember, when we divide, that means you're going to go more than one full revolution. How do I know if I'm going more than one full revolution?
If it's more than twice the denominator.
Good. If it's more than twice the denominator, that means we're going more than one full revolution. Luke, you're not even trying to hide your phone being rude to me. Okay, so are we going more than one full revolution? Yes, because the numerator is more than twice the denominator. So we divide. We're going to take our number in our numerator, and we are going to divide by twice the denominator. So 6 goes into 8 once. We subtract. 8 minus 6 is 2. That is our remainder. Our remainder is 2. So now our new reference will be the cosine of 2/3 pi. So that remainder replaces the numerator. The denominator stays the same. Now what we want to do is we want to set up our circle or our axes, and I want everything to have the denominator of 3 if possible. The first time I'll write out our normal reference angles. So this is 0, this is 2 pi, this is pi over 2, this is pi, and this is 3 over 2 pi. But now I want to make everything have the same denominator as the angle in the problem. So my denominator is 3, so I want to make all of these reference angles 3. So this is going to be 0 over 3, 6 pi over 3. Can I change a 2 into a 3? No, so I leave it. I leave pi over 2. I will change pi into 3 pi over 3, and I can't change 3/2 pi. I leave it. So now I want to sketch 2 pi over 3. Which quadrant will 2 pi over 3 be in? Tice's friend, leave him alone. He's studying.
No, Tice's friend is not out there.
You're shaking your head at somebody out there.
What do you mean?
Guys, like it's insane.
Nah, that was crazy. I was looking at this one right here. What?
Okay. Which quadrant am I making this triangle in?
2.
Quadrant 2. Why? Because this is 3 pi over 3. And we move counterclockwise, right? So anything below this would be bigger than 3 pi over 3, like a 4 pi over 3. But 2 pi over 3, wouldn't that be just right above it? So that means we're in quadrant 2. So I'm going to make my triangle. And how do we find the reference angle? Anybody remember?
180 by 3.
Good. To find the reference angle, you're going to divide. So for the reference angle, divide 180 by the denominator. So we're going to do 180 divided by 3 is 60 degrees. So if this is 60 degrees, we know this is a 30, 60, 90 triangle. Opposite the 30 is root 3. I'm sorry, opposite the 60 is root 3. Opposite the 30 is 1. Opposite the 90 is 2. Which ones will be negative, if any? just the 1. The root 3 is going up, so it's positive. So now I want the cosine of this. So this brings us back to SOHCAHTOA. So if I want the cosine of, I'll write it here, cosine of 8 over 3 pi, it is going to be my adjacent, which is -1, over my hypotenuse, which is 2.
If I put cosine 2 over 3 pi equals the answer, like, is that going to be wrong?
I technically wouldn't take points off, but I want you to write the original. Okay, how about you guys try number 3 on your own? Oh, I'll write it down. So you guys try this one on your own.
No, but I think it's crazy.
That's a big number.
Oh, yeah.
It's fine.
It's because I love that mixed metal. I love this seed. That's why. Does it hurt if you feel?
Do you guys want me to go back to my work for the other problem?
No, I know how to do it.
This earring just fits so well.
Yeah, it's just a big number.
A while. This is the newest one. And it's up there, but they'll also heal. And they'll
I muted it because I was talking about the piercings. My fans didn't need to hear.
They would like to know that information. Ears piercing and all that.
Yeah.
With the 40.
So maybe just get one and then the one up here?
Yes.
Girls. Just do one more here and then one up here? Or just do two here and that's it?
When you pay for piercings, you pay for two at a time.
Yeah.
So, yeah.
But no, I'm doing it both sides.
Right, but the one up here. You can't get both at the same time because they usually don't let you do that because you have to sleep in one room.
So as it says, like when I got my piercings, I said, well, I just wanted this one, like
Yeah.
I know all I wanted, but I paid for two. Because I was like, I only want one. They were like, you can get another, or like
The earring. You pay for the piercing and the earrings.
Yeah, that makes sense. And the earrings come in pairs.
Yeah. So,
But you could only...
You pay for the service. You pay for the service, the piercing itself, and the earring.
oh, I went to La Vista in the mall and I just paid for the earrings.
Okay, well I didn't do that.
Wait,
When you get it up here, get it with a needle. You have to go somewhere special. Get it with a needle. That's a lot healthier.
I got mine at Claire's and it healed so well.
I wouldn't go to Claire's.
I wouldn't go to Claire's either.
That's like suspect. Where did you go? And they were good?
But then,
Are yours symmetric? Like, did they do them in good spots?
yeah, I had to get my second three pierced, and then I got my thirds, and I got my cardio.
So that's my question. Do I just do the seconds and the thirds or just the seconds?
You could just, depending on how you feel about the seconds, like, do you have like a high pain tolerance?
Probably
Because my
not.
thirds hurt, and I have a high pain tolerance.
Your third up here hurt?
It hurts.
Why?
Because it's like thicker up here. Like,
Oh.
it's my cartilage.
It depends on the person. Like for me, I had no.
At Claire's?
It's a root.
Claire's in the Vista in the mall.
But up here, did up here hurt
My
you?
cartilage was fine. Like, I didn't even feel it.
It just depends on the person.
That's crazy. All right, guys, we need to go over this, right? No, we're just going to go over it. What should be your answer? Your answer should be, I'm just going to give you the answer, and then we'll do it if we need to. Root 2 over 2. Who wants me to do it?
Matt does.
Me? Okay.
You put the one, right?
What one?
I got one.
There's no one.
If it's a one, you
It's not 1. It's root 2 over 2. All right, let's do it. So, first question, do we have to divide? Yes, because we're going more than one full revolution, right? So we're going to take 223 and divide it by 8. 8 goes into 22 2 times. 22 minus 16 is 6. Bring down the 3. 8 goes into 63 7 times. 8 times 7 is 56. So our remainder is 7. So now we're going to sketch the cosine of 7 over 4 pi. So now I go and I set up my chart, and are you guys okay if I make the denominator 4 right away? Yeah? Okay. So then we're 0 over 4, 8 pi over 4, 2 over 4 pi, 4 pi over 4, and 6 pi over 4. So now I want 7 pi over 4. So where will 7 pi over 4 be? Which quadrant? 4. Now I need to make my reference angle. How do I find my reference angle again? 180 divided by 4, which is 45. Because this is 45 degrees, it's a 45, 45, 90, so we're 1, 1, root 2. Which of these, if any, are negative? The one going down. To the right is positive, going down is negative. So now, I wanted, again, this was cosine, so we're back to SOHCAHTOA. So I want adjacent and the hypotenuse, everything in reference to this angle. So adjacent to 45, so now we're doing the cosine of our original problem, which was 223 over 4 pi. Adjacent is 1, the hypotenuse is root 2. Can I leave a radical 2 in the denominator? No. So now I rationalize. Multiply top and bottom by root 2, and we end up getting root 2 over 2 as our answer. Oh, you kept it 1 over root 2. You have to rationalize. We don't leave a radical in the denominator. All right, next one. Should we do a negative one? Do you guys want me to do number 2? Yes. All right, we'll do number 2, and then we'll go on to a different section. How about, oh, no, but we have to do number 4, too. All right, we'll do number 2 and 4. We'll do number 2. Number 2 is the tangent of negative 91 over 6 pi. Obviously, 91 is more than a full revolution, so we're going to do 91 divided by 12. Don't worry about the negative right now. We're just dividing.
So what number is this? 2?
Number 2.
Section?
In the same section.
Oh, okay.
When we're dividing, we don't keep the negative sign. We're just figuring out the remainder, and then we'll put the negative back in. So now when you divide this, we're going to get, I'm just going to tell you, we'll get a remainder of 7. Do you want to see me divide it? Yeah? Okay. 12 goes into 91 7 times. 7 times 12 is 84. Subtract, we get a remainder of 7. So now we're going to be working with the tangent of negative 7 over 6 pi. I'm going to make my denominator 6 right away. So we're going to have 0 over 6, 12 pi over 6, 3 over 6 pi, 6 pi over 6, and 9 pi over 6. Oh, sorry, this was negative. Sorry, because it was negative, everything has to be moving the opposite direction. Sorry, when it's negative, you don't go counterclockwise, you move clockwise. So you go from 0 to negative 3 pi over 6, and then negative 6 pi over 6, and negative 9 pi over 6 because of the negative. So where am I making my triangle, in which quadrant? Which one? In the second, good. We're in the second quadrant. My reference angle, yeah, is going to be 180 divided by 6, which is 30 degrees. So we're left with a 30, 60, 90. Opposite 30 is 1. Opposite 60 is root 3. Opposite 90 is 2. The only negative is the root 3. And we're going to SOHCAHTOA this. And tangent is TOA. So now I'm going to take the tangent of negative 91 over 6 pi, and that's going to be the opposite, which is 1, over the adjacent, which is negative root 3. Can I leave it like this? No, I need to rationalize. So the tangent of negative 91 over 6 pi will be root 3 over negative 3. I just multiplied top and bottom by root 3. Okay, you guys try actually number 4. You guys try number 4 on your own. Oh, sorry, you guys don't know what number 4 is. Number 4 is the secant of 100 pi. This is a special case.
Oh, is it a unit
Good, Matt. What'd you just say? Unit circle. This is a unit circle.
Yeah, I forgot.
One looks funny.
So I'm upset because the type is calling me and if I can find and switch up. So I'm like, okay. So I ordered one on Amazon. I also had to go tomorrow, like someplace like 40 minutes away to go find it. Go find something. I found like a custom type that's like 20 minutes away.
I feel like you'll be fine.
Yeah, I'm fine, but it's okay.
Is this gonna be on the quiz tomorrow?
Yeah.
What happened?
Is this gonna be on the quiz tomorrow?
Yeah,
Like actually?
sure.
Cause like, how many questions?
How do we do this?
Yeah.
All right, let's do it. I know it's on the unit circle. How do I know that it's on a unit circle? Because our unit circle is 0, 2 pi, pi over 2, pi, 3 over 2 pi. And isn't 100 pi a multiple of 2 pi? So that's what we're doing. 100 pi is a multiple of 2 pi. So that brings us right here to the point 1, 0. So now for secant, isn't secant the reciprocal of cosine? And cosine is x over r. So what does that mean for secant? Will be r over x. What's the r on the unit circle? Yeah, but what is it always? What number? R is always 1. So this is going to be 1 over the x coordinate, which is 1. So the secant of 100 pi is 1.
Wait, how did you get one numerator?
How did I get 1? Because secant is r over x, and the radius in the unit circle is always 1.
Oh, okay. So you just ignore that.
Radius always 1.
Okay.
All right, I'm going to make one up right now.
Are we gonna do ones that are converted from
Yep. We'll do all those. Okay, try this one. This is, I'm just making this up. I want you to do the, I don't know, tangent of 2 over 4 pi.
When you're doing the radian stuff, you're basically just like focusing on these two numbers and then just like minimizing them as much as possible and slapping the pi on there. Okay. I think I like changing to degrees more. It's fun.
So guys, what should you have realized? This is, again, is what? This is on the unit circle. So if you make your common denominator, this is 0 over 4. This is 8 pi over 4. This is 2 over 4 pi. This is 4 pi over 4. And this is 6 pi over 4. So when I ask for the tangent of 2 pi over 4, that's right up here. So this is the point 0, 1. And now tangent, if you remember, is y over x. Tangent's y over x. So my y coordinate is 1. What's my x coordinate? 0. What happens when you have 0 in the denominator? What does that make it? Undefined. All right, so you've seen every scenario of this. Can we move on to the next section? Okay, so that was section 1. This is section 2. We want to, Nico, how am I doing on time? Find x if,
24 minutes.
okay, good.
Perfect, we're fine.
So find x if 0 is less than or equal to x, which is less than 2 pi. Notice the 2 pi doesn't have the equal to sign. So your answer can be 0, but it cannot be 2 pi. Your answer can be 0, but it cannot be 2 pi. So the first one I'm going to do with you is number 7. This is saying the tangent of x is equal to root 3 over 3. Right, this has been rationalized. I'm going to tell you, go back to before the rationalization. So how do I go back to before the rationalization? Don't you just really undo that square rooting? So go back. I know this would have had to be the square root of 3. What is that numerator then? If I had to multiply top and bottom by the square root of 3, wouldn't this have just been 1? Now this time we're finding the missing angle. We need to know what is the angle that gives us this. Well, this is where, this was probably the most complicated of what we've done. This goes back to the all students take calculus. And do you see, what is that noise? Okay, so do you see how the tangent of this angle is positive? Because the tangent of this angle is positive, I have to work in the quadrants where tangent is positive. In which quadrants is tangent positive? 1 and 3. So that means 1's a winner, 3's a winner. If you guys remember, I gave you a little shortcut tool. This is just theta. This is going to be pi minus theta. This quadrant will be pi plus theta, and this will be 2 pi minus theta.
Well, when did we do this?
It was the last day, day 3.
Was that when it was your Monday? I don't think so.
That's okay.
And then we had 2 answers.
We're going to have 2 answers, yeah? All right, are we ready to do this? Not yet? All right, let me know when you're ready.
You're not going to give that to us, right?
You have to know it. I'm not going to give it now. But you can just write it on your paper right away when you get it. Okay, so now I'm going to start. We said we're in quadrant 1 and quadrant 3. I'm going to make my triangle first in quadrant 1. And here's my theta. And isn't tangent based on SOHCAHTOA? Tangent is the opposite over the adjacent. So that means opposite theta is 1, adjacent to theta is 3. Based on how I label things, what angle does theta have to be? Theta is 30 degrees, but I want 30 degrees as radians. So then theta is pi over 6. So if you guys remember, 30 degrees was pi over 6. What was 60 degrees? Pi over 3. And 45 degrees was pi over 4. Well, guys, you've sort of been doing this the whole time. Anytime the denominator was 6, remember, you'd be like, oh, the reference angle's 30 degrees. Anytime the denominator was 3, oh, the reference angle's 30 degrees. Anytime the denominator was 4, oh, the reference angle's 45 degrees. It's all based on that denominator.
Oh, so it's just the same thing with pi.
Yeah, pi is 180.
Oh, okay.
Yeah, that makes more sense. I was like,
It just like looks fun.
Okay, so now are we all now in agreement that theta is pi over 6? All right, so now we have to figure this out in the right quadrants. Well, we said in quadrant 1, our answer is whatever theta is. So what is theta? Pi over 6. That's one answer. But then our other answer is in quadrant 3. So in quadrant 3, x is equal to pi plus theta. So I'm going to take pi and add my pi over 6 to it. In order to add these, what must I create? Common denominator. So this is 6 pi over 6 plus pi over 6 gives us 7 pi over 6. So these are our two answers, pi over 6 and 7 pi over 6. I think you need to try one of these on your own.
sorry, how did we get pi over 1 plus pi over 6?
So your answer when it's in quadrant 1 is just whatever theta is. Your answer when it's in quadrant 3, you add pi plus whatever theta is. So we figured out that theta right here was pi over 6. So that's our answer since it's in quadrant 1. That's one answer. But the other answer will be in quadrant 3, so you add pi to the pi over 6. Because everything in this answer, think degrees, right? Everything that our answer was 30 degrees, right? But in this quadrant, it's not 30 degrees. It's 180 plus 30 degrees. So that's why it's the pi, which is 180 plus our 30 degrees. But our 30 degrees is pi over 6 when we're dealing in radians. All right, I'm going to have you guys try this one. This was number 6 from the review. Cosine of x equals negative root 2 over 2. This is something that's been rationalized, so unrationalize it, if that's a word.
Derationalize.
Derationalize, I like it.
We're like 15 minutes solid.
I mean, the last two sections are easy. I only probably have to do one of
Very easy,
each.
yeah.
It's more the first two sections.
Well, should you give me Z in the circle problems, honestly?
I should do more of them.
No, I mean,
Oh, I
I'm
did
just
6
saying.
already.
That's fine with mine.
You did 6? Good.
Last one.
Okay.
When everything's positive for one. Yeah, cosine negative. Oh, so all this was. Yeah.
No, I thought this one was
Yeah.
I didn't know what your preference angle is.
Yeah, this is
Based on the triangle, like you know, it's either going to be 45, 45, 90 or 30, 60, 90. So based on how you label the sides.
I have the triangles. I know what the triangles are. I just don't know if it's 45 or 4.
So you have to label the sides.
Like no matter what.
So see how it's, what is this, negative 1 over root 2?
Yeah.
So this was cosine. Was it cosine?
Yeah.
Okay, so that means here's your angle. So
You gotta
adjacent
set it up in
is
there.
Oh, like it has to
1,
be.
Just has
and then
Usually
the
the top one, but yeah,
hypotenuse
set it
is
up.
2.
Okay, yeah, like it
Which
has to
means
be.
this has to be what kind of triangle? Exactly.
This is
So,
it's like it's adjacent to hypotenuse.
well, so you see how that's rationalized. You have to like de-rationalize it. You just gotta make the triangle.
What's up, Devon?
If you know,
I mean, it's probably a 45.
if it's in both of these,
Mm-hmm.
how do you know which equation?
You just pick one, because all you have to do is find the angle. Once you find the angle, once you know what the angle is, then you can just go from there. So do you know what the angle is? So then from 45, pi over 4, so you're going to do pi over 4, pi minus pi over 4 is one answer. And then it'd be pi plus pi over 4. So you'd have to make a common denominator to add them. So that first pi's over 1, right? So it's pi over 1. So we make a common denominator of 4.
So it's and I still need to do this one.
Top and bottom by 4. So it'd be 4 pi over 4. Plus pi over 4, which gives us 5 pi over 4. That's one answer. But then just subtract, exactly.
You just get 2.
Yeah, you're always going to have 2 answers because you have an answer for when it's in this one and an answer for when it's in this one. All right, let's go over this. So the first thing we have to do is de-rationalize this. I like that word, Nico. I don't know if it's a real word or not. So then we'd get negative 1 over root 2. Did everybody de-rationalize it correctly? Anybody not? We got it? Okay. So now what I want to do, because this is negative, I have to figure out which quadrants we're going to be in. So we're all students take calculus. But remember, cosine is negative. So in which quadrants will cosine be negative? Quadrant 1 is out. Will cosine be negative in quadrant 2? Yes. Will cosine be negative in quadrant 3? Yes. Will it be negative in quadrant 4? No. So remember, this is just theta, this is pi minus theta, and this is pi plus theta. Once you know your reference angle, like if you could figure out your reference angle without drawing the triangle, you don't have to draw the triangle. What do I mean by that? So I know which triangles root 2 in. A 30, 60, 90 or 45, 45, 90? 45, 45, 90. So I know right here it's 45 degrees. But let's say you didn't know. Let's say you didn't know it was 45 degrees. Then you'd go and pick a triangle. You'd pick a quadrant and draw your triangle. You'd name this theta. And because this is cosine, this is the adjacent and this is the hypotenuse. So adjacent to theta is 1. The hypotenuse is 2. So this is the negative. And then at this point, I hope you realize that theta must be 45 degrees. So now we're going to say, okay, well, 45 degrees in radians is going to be what? Pi over 4. Remember, pi is just 180. 180 divided by 4, that's 45. So now, But now I'm not in quadrant 1. If I were in quadrant 1, then that would just be my answer. But I'm not. I'm in quadrant 2. So to find my answer in quadrant 2, what do I have to do? Pi minus pi over 4. In order to subtract these, what must I create? Common denominator. So I multiply top and bottom by 4. So I get 4 pi over 4 minus pi over 4, which gives us 3 pi over 4. That's only one answer. And I don't only have one answer. Why? Because I also have another answer in which quadrant? In quadrant 3. So in quadrant 3, we have pi plus theta. So this is going to be pi plus pi over 4. Once again, what do I have to create? A common denominator. Multiply top and bottom by 4. So we're 4 pi over 4 plus pi over 4, which gives us 5 pi over 4. Those are our two answers. How am I doing on time? Okay. Do we want to do a unit circle one? See one of those? All right. This is, let's do number 8 from the review. This is number 8. This is going to be cosecant equals, cosecant x is -1. So do we agree this would be -1 over 1?
I would agree with that.
Oh, wait, this could actually be, and what is cosecant? Cosecant is the hypotenuse over opposite, right? Because it's a reciprocal of sine.
You almost said opposite.
Yeah, opposite. So cosecant is hypotenuse over opposite. In all the triangles we know, 30, 60, 90, will the hypotenuse ever be 1? No, because this isn't looking like a 30, 60, 90 sides, like 1 in root 3 or root 2 or any or 2. We know that this has to be unit circle because it's not looking like any of the triangles we know. It's not numbers that we normally deal with. So what does that mean?
Wait, where's the pi?
Oh, I'm not there yet. I'm just telling you, we're still trying to find it. So this is just -1 over 1. So we're trying to find the angle. So we know this is unit circle. This is 0 and 2 pi. So that's 1, 0. This is pi over 2. That's 0, 1. This is -1, 0. That's pi. And 3/2 pi is 0, -1. So now, because we're on the unit circle, this is going to be r over y. Well, we know the r is always 1, right? So where is my y -1? Where is y -1? 3/2. Is that the only place y is -1? Yes. So I only have one answer here. X is equal to 3/2 pi. Okay, I want to do one of each of the remaining sections just so you see. All right, part 3, we're changing to degrees. So when we change to degrees, I'll do number 11. What you're going to do is multiply by 180 over pi. So when we change to degrees, we're multiplying by 180 over pi. So we have 3 pi over 5. And what I'm going to do is I'm going to multiply by 180 over pi. Do we agree I could cross simplify? The pi's cancel? Then I can cross simplify more. 5 goes into 180. 30. Thank you. Or no, not 30. 6 goes into 180. 36. So then what am I left with? 3 times 36, which is 108. And then the last section, change to radians. We multiply by pi over 180. So this is number 14. If I have 250 degrees, what I'm going to do is take 250 degrees, multiply by pi over 180, and then I cross simplify as much as I can. I cancel out those zeros, and then I'm left with 18 and 25. Is there a number that goes into 25 and 18? No, there's no number. So this is just going to be 25 pi over 18. Or 25 over 18 pi. All right, we did something of everything. You guys should be in good shape. If I